We are about to conclude the first volume of the three-part series on functional programming. The purpose of this volume is to equip you with the mindset required for functional programming. Instead of a book or lecture format delivering you the dry theory and wishing you good luck to understand it, you had a chance to understand the basic concepts of functional programming by implementing practical examples. If you rewatch section 1 with your current knowledge, you will see that it acts as a great summary on what you have learned. Although our first examples in this section act as a teaser, with your current knowledge, you will be able to understand the examples on a deeper level. Beyond the code examples, you also had a chance to compare and contrast functional programming to object-oriented programming. In addition, we generalized the benefits of writing declarative code. You focus on the what question rather than how. There are of course some drawbacks of functional programming, and you had to wait until the section on recursion to learn some optimization techniques that combat some disadvantages presented in section 1. One more important takeaway for this section is that you learned mostly functional programming and not pure functional programming throughout the course. As we are writing JavaScript code, we will rely on imperative elements of the language from time to time. Talking about JavaScript, the goal of section 2 was to show you how you can use the modern version of JavaScript, ES6. I have read so many functional programming books and watched so many courses, and I was fed up with having to read the old ES5 syntax, especially when it comes to nested functions and variable number of arguments. The ES6 syntax is not only intuitive, but it also reminds you of other purely functional languages. Some elements of ES6 were hidden from you in this section. For instance, we only talked about maps in the section on recursion. In fact, we will only talk about promises and the ES 2017 async await language construct in the next volume. Cloning seems to be an off-topic at first glance, but it is essential to understand the different types of copying methods if you want to write programs in mostly functional style. This is a very important section, so if you can't tell the difference between deep and shallow cloning right after you are woken up with a question, go back and watch this video once more. Back when you learned about context binding, it is likely that you didn't see the connection between the JavaScript bind function and partial application. Now you can connect the dots by contrasting these two videos in sections 2 and 4. Chaining, function composition, and function sequencing were also useful techniques in your functional programming utility belt. Especially when it comes to chaining, be aware that we are writing applications in JavaScript, so it makes perfect sense to rely on the this context and chain function applications after each other to construct readable values. The section on higher-order functions is a practical application of chaining in itself. After some introductory sections on what higher-order functions are, you learned some array operations that were necessary for you to understand the rest of this section. We then introduced map, reduce, and filter, and the rest of this section was about chaining these operations after each other for the purpose of solving practical problems. You learned the connection between MapReduce and SQL, and you also learned how to convert an array of nodes to a tree. The fourth section was all about querying and partial application. As functions can return functions, we can transform a function with any number of arguments, or using its name arity, to a sequence of function applications each having one argument. We implemented querying and partial application using the bind function and experimented with the built-in query and partial functions of the Lodash library. If you liked Lodash, you will also like volume 3 of this series, where we will dedicate a section on using Lodash in practice. We concluded this section with the implementation of a simple template renderer function using partial application. Although the whole course was about using recursion, we dedicated a section on learning this technique on a deeper level. After some definitions, you learned the connection between recursive and iterative solutions. This means that in the future, whenever you know the recursive definition of a problem, You will be able to implement it iteratively, and you will also be able to rewrite iterative functions using recursion. Accumulator variables were the cornerstone of traversing between recursion and loops. Accumulator variables are also important for tail call optimizing a recursive function. Beyond tail call optimization, you also learned two other optimization techniques, mostly functional programming and memoization. Imagine that you are a superhero with a utility belt containing different weapons for different purposes. You can use any of these tools to tackle your challenges using functional programming. ES6, recursion, high-order function, currying, partial evaluation, function composition, function sequencing, and chaining make it possible for you to write elegant functional code.